Hello, we're south of Drayton in the Conestogo Lake area, and the quaternary units that we find at the surface along road cuts like this are related to the last deglaciation, and for the most part they're the deglacial till sheets like the Mornington till and the Tavistock till that were deposited by the Huron-Georgian Bay lobe, so ice essentially flowing from the Lake Huron Basin to the south-southeast into this area. The deglacial tills like the Tavistock, the Mornington tills, they're quite often fine grain, lots of matrix, and so very fine sand and silty matrix. And if you dig deep enough, you get the true color. The material in this case, you see it's nice sort of brown buff color, and if you take a close look at the texture here, you see it's very fine grain, lots of silt in there, and it's a till. It's massive, and again, the reason why it's called a till is because this massive diamicton has lots of faceted clasts with polished surfaces and striations. So you see lots of carbonate rocks with the nice striations and the subangular and angular shape. In the Conestogo Lake area, the Mornington and Tavistock tills are interstratified with glacial lake sediments. Now these are laminated sediments, very fine grain, mud rich, but you do see some coarser layers. The light tone laminations are slightly coarser. They're very fine sand to silt, and then the darker layers, because they have a bit more moisture, they're darker. Those ones are clay rich. So you have this alternation of clay rich layers and silty layers. These are referred to as rhythmites because of the rhythmicity that we often find in these laminated sediments. And sometimes these are due to seasonal changes, and like the summer layer will be coarser because of more meltwater coming in the lake, and in the winter you have ice cover, it's more quiet, and you have settling fine grain sedimentation. So when it's seasonal like this, when it's annual, it's called varve. But if you're not sure of the cyclicity, then you just call them rhythmites. The reason this is interpreted as a glacial lake deposit and not just a lacustrine deposit, it's because of two reasons. The first one is the face sheath association. When you consider what's below and what's above, you find diamictons of glacial origin. So these lacustrine deposits are sandwiched in between till sheets. So then that's the first clue. And then the second one, which is quite important, is that these laminated sediments have angular pebbles that are like isolated pebbles like this that are found within that sequence. There aren't many processes that can deposit a clast, a subangular and striated clast in the middle of a laminated package of sediment. So think about it for a moment. So when you see angular pebbles like this, especially if they're polished and striated, when you see angular pebbles like this isolated within a package of laminated fine-grained sediments, which on top is, sandwiched in between till sheets, you can be quite confident with the interpretation that this is an ice contact glacial lake. And these clasts are also referred to as drop stones and also ice rafted debris. So and the reason is because the only way you can bring these clasts in this lake and these lacustrine sediments is if they're dropped by floating icebergs. So if you have debris-rich ice floating, like icebergs, debris-rich icebergs that are floating on the lake, they're melting, they're going to drop their load, and they're going to drop sometimes large clasts like this, and then they settle down and they get buried by more and more layers of lake. So when you see this, then you know that the ice is in contact with the lake, it's calving, it's releasing icebergs that are debris rich, and it's dropping stones like this in the lake deposit.